Alright, continuing here with uh, the prerequisite section 3 in Trig here. Continuing on, we are now on example 5, and we are dealing with exponents and different laws of the exponents. So here's what I'm going to do. We're going to go through this piece by piece, and the first piece here is, let's just worry about the numbers, and since this is multiplication, we have a 3 and a 4, so 3 times 4, which is 12. Okay, no problem. Now we're going to move on to the x's. Okay, we have an x to the third and an x. Well, keep in mind that x, that regular x, is like saying x to the first power. So that's just something for you to keep in mind, that we actually do have an exponent there. So this is x to the third and x to the first power. So what that means is x to the third and x to the first, according to our rules, you need to add them. So 3 plus 1 is 4. So you end up getting x to the fourth power. And now we are on to the y's. We have a y to the fourth and a y to the fifth. So you take the exponents and you add them together. So y to the fourth and y to the fifth. You get y to the ninth power. Alrighty, so there's your answer. So looking at example 6 here, I can't just do anything with that 2 like in the last problem, because I have this right here on the outside. I have this 4, which means I need to take that 4 through to every single item. So I'm going to have to also take it through that 2. And that 2, it's like saying I have an exponent of 1. So 2 to the first power. So 1 times 4 is 4. That's why I get 2 to the fourth power. Then I have that 4, and I have to take it through to the a squared, so 2 times 4 is 8, so that's really a to the 8th power. And I have a b to the third to the 4th, so 3 times 4 is 12. And I have a c, and that's like saying c to the first power, remember. So 1 times 4 is 4. And 2 to the fourth power, I could rewrite it if I wanted to as 16. So 16, a to the 8th, b to the 12th, c to the 14th. Example 7 here. Before I do anything, before I multiply these two together, I need to take that through. Right? Remember, order operations, I have to do parentheses, so I got to do what's in the parentheses first, which means I have to take this 2 through to every single item, even in the denominator. And remember, I have to take it through to the numbers as well. So it's like saying 2 to the first power. So 2 to the first squared is like saying 2 squared. Then I have to take it through to that r. So r cubed squared, it's like saying 3 times 2, which is 6. So it's r to the 6th power. This bottom, remember, that's like saying s to the first power. So 1 times 2 is 2. So it's s squared on the bottom. So then over here, let's move on to this one. This s is like saying s to the first power. So 1 times 3 is s to the third over, right, 3r to the cubed, so 3 times 3 is 9. Okay, so when I push everything together, I just went right across the top. Since nothing is the same on top, right, nothing is the same, I just put it all right across. Since nothing is the same on the bottom, I just put it right across. And 2 squared I rewrote as 4. So now I find items that are the same. There is no other number on the bottom, so it's just a 4 on top. But I have an r to the 6th and r to the 9th. Well, which one's bigger, top or bottom? The bottom is, right? So our answer is going to go on the bottom, r to the something on the bottom. Well, when you do this, if you remember, 6 minus 9 is negative 3, so it'll be r cubed on the bottom. The s's are s cubed and s squared. Well, which one's bigger, cubed or squared? Cubed's bigger, which means the s is going to go on top. So 3 minus 2, according to our law there, is s to the first power. So it's like saying s over 1. So here's what I have. I have 4, and I have a 1 on the bottom. I have a 1 over r cubed, and I have an s over 1. So just multiply the tops to get 4s, multiply the bottoms to get r cubed. And I know I'm done because you can't have negative exponents so there is no negative exponents. You can't have fractional exponents. There is no fractional exponents. And every single, there's only like one S, there's only one R. They're all simplified. Okay, so looking at this one now, example 8, let's take this negative through. Negative 3 times negative 2, that's going to change into a positive 6, so it's u to the 6th. Negative 3 times 3, that's negative 9. Now this is negative. The whole thing's not negative, just v. v is the only negative. Since v is the only negative, that's what's moving down to the denominator. Since v is the only negative, v is the only thing that moves down, and you get u to the 6th over v to the 9th. So I flip that onto the bottom.
Gentlemen, you have my demands. Peace out.
So good question here. What if both exponents are negative?
I invented the piano key necktie! I invented it!
So here's what that means. Basically, if you have a negative on the top and you have a negative on the bottom, you just flip-flop them both. Just flip them both. If you have something that's negative on the bottom, that moves to the top. If you have something that's negative on the top, that means you move to the bottom. So whenever you have a negative exponent, you move it on the other spot. If you have a negative exponent on the bottom, move it up top. If you have a negative exponent on the top, do what we've been doing. Move it to the bottom. So notice how it was now b to the n on top and a to the m on the bottom. So I have x to the negative 4 on top. That means that needs to go to the bottom. So that would be x to the 4th on the bottom. I have 2 to the negative 8 on the bottom, so that means I have to have 2 to the 8th on top. Just flip them. And 2 to the 8th is 256, and x to the 4th is x to the 4th.
Hot pot of coffee!
Alright, so looking here, let's start with the numbers, right? 8 over 4, well that simplifies to 2 over 1. Let's take a look at the x's now. X cubed and x to the negative 1. Still do everything the same, okay? What do you do with fractions? Let me put the 2 there, but what do you do with fractions, right? You subtract. 3 minus negative 1. 3 minus negative 1 is like saying 3 plus 1. You end up with a positive. Once again, still the same rule applies. Which number's bigger? That 3 or negative 1? 3 is. So, because 3 is the biggest one, notice how x to the 4th will go on top. Look at the y's. Y to the negative 5 and y squared. Still go through the motion, still subtract. Negative 5 minus 2, you get y to the negative 7th. Which one's bigger, the 2 or the negative 5? Well, the 2 is, and the 2 is on the bottom, which means the y's are on the bottom. So it'll be y to the 7th on the bottom. And there's your answer. So with this one, we take that negative through to every item. So u squared to the negative 3 is like saying u to the, when I multiply them, negative 6. I have to take this 2 through, or that's 2 to the 1st, so I have to take that through there, and I got 2 to the negative 3, and I have to take it through to the v, so I got v to the negative 3. I have negatives all over the place. If I have a negative on the top, I move that to the bottom. If I have a negative on the bottom, I move it to the top. So I have to flip them all. I have to flip anywhere where there's a negative. So that 2 to the negative 3 goes on top, be 2 to the 3rd. And that v to the negative 3 goes on top. That becomes v to the 3rd. And this u moves to the bottom, so I get u to the 6th power. And 2 to the 3rd is like saying 8. So it's 8 v to the 3rd, u to the 6th. Alright, when we come back here, we will finish up with scientific notation.